Hi, welcome again to my channel. This is where we learn mathematics, and today we are going to learn about complex numbers. In this course, I'm going to show you the definition of complex numbers and examples of complex numbers. Let's start with definition of complex numbers. A complex number is a number of the form z equals a plus bi, where a and b are real numbers and I square equals -1. If I square equals -1, then I equals square root of -1. In this form of complex numbers, z equals a plus bi, the number a is the real part and b is the imaginary part. This means a complex number has two parts. It has real part and imaginary part. A is the real part and B is imaginary part. We can write that real part of Z equals A and imaginary part of Z equals B. We have examples. Example number A, we have the complex number Z equals 3 plus 2i. Let us identify real part and imaginary part. Here, the real part equals 3 and imaginary part equals 2. You can see, if we have this complex number z equals 3 plus 2i, this 3 stands for A. 3 stands for A and 2 stands for B. Since the complex number is of the form a plus bi. By comparing 3 plus 2i and the general form of complex number, you can see that a equals 3 and b equals 2. Therefore, the real part equals 3 and imaginary part equals 2. Let's see the next example. The next example is example number B. We have the complex number z equals 4i minus 5. When we have this complex number 4i minus 5, this is the same as minus 5 plus 4i. When we compare with the general form of complex numbers a plus bi, the real part of this complex number equals -5 and imaginary part of this complex number equals 4. Next example is number C. We have z equals 9i. This is like 0 plus 9i. It means that a equals 0 and b equals 9. So the real part is equals 0 and imaginary part equals 9. Another example is example number D. We have the complex number z equals -23. This is the same as -23 plus 0i. So the real part of this complex number equals -23 and imaginary part of this complex number equals 0. You can see, if the real part of the complex number equals 0, we obtain a complex number with bi. Look this example C, 9i. And if the imaginary part of complex number is 0, we obtain a complex number with a. Look this example number D. This results in some remarks. Let's see these remarks. First one, a complex number whose real part is 0 is said to be purely imaginary. Here, a complex number is said to be a purely imaginary if its real part is equal to 0. If the real part of complex number equals 0, then we obtain the complex number with bi. Because a is equal to 0, now it is 0 plus bi. If this is 0 plus bi, then we obtain bi only. That's why it is purely imaginary. It contains imaginary part only. Let's see the next. A complex number whose imaginary part is 0 is said to be a real number. We have the complex number a plus bi, right? Now, if imaginary part is 0, it means that b is 0. If b is 0, this number will be a plus 0. If it is a plus 0, it is equal to a. So the complex number will be a plus 0. This is equal to a. So this complex number contains the real part only. So this number is known as a real number. And all elements of real numbers are the elements of complex numbers. From this remark number 2, this one, you can see that if imaginary part is 0, then the complex number becomes a real number. So this implies that any real number is equivalent to that real number plus 0i. Then it becomes the complex number. So all elements of real numbers are the elements of complex numbers. Here we can write all elements of real numbers are included in complex numbers. Or simply we can say that a set of real numbers is a subset of complex numbers. We have exercises. First one, show the real and imaginary part of the following complex numbers. Here we have the complex numbers. You are required to identify real part and imaginary part. Here we have z equals 7i minus 10 and b equals 45i. Question number 2. For each of the following numbers, state whether the complex number is purely imaginary, real, or neither. As we have seen, a complex number can be purely imaginary, it can be a real, or neither purely imaginary nor real. Now determine if the given complex number is purely imaginary, real, or neither. We have a, z equals minus 2i, and b, z equals 7 minus 3i, and c, z equals 16. Try this exercise and check the solution after some seconds. Then compare with your obtained results.